Okay, so let's talk through and look at a simulation for motor starter start station with memory. So on the top here we have our three-phase power circuit for our motor. Of course, we have our disconnect 1, fuse 1, 2, 3, contactor 1, overloads 1, and together those are motor starter 1. And then we have our motor 1. This is a 208 service, three-phase. So I have that black, red, and blue. Of course, I can open and close my disconnect. Well, I'll keep it close so I have power ready to apply to the motor. Now on my bottom circuit, I have my control circuit. I have my push button 1, start, push button 2, stop. Of course, my start is open normally, stop is open normally. I can press it, sorry, my stop is closed normally. I can press it open. When I let go of it, it closes, right? So it springs back to its normal state. Contactor 1 coil will energize and close these contacts here, and then my overload depending on my current of my motor. And so let's simulate this and we'll run. And this is in a start stop without memory, no memory. I'm going to get to this rung 2 in a minute, but if I simply have my push button pressed to engage the contactor 1 coil and close those contacts, my motor is spinning now. But then if I let go of that start button, it springs open and the motor's off. This would be a jog scenario. Jog it on, let go, it turns off automatically. Now, if I wire an alternate path around my start button, so if I have a start button and I want more than one way to turn on the contactor 1 coil, I want to be able to turn on by the start button or by an aux contact off of contactor 1, then I do that in parallel. So when I have multiple things turning something on, I do that in parallel with a normally open. So I can just run the contact off of contactor 1. This is my aux contact. So this is my fourth contact off of that contactor. I have 1, 2, 3, and now my fourth one I can put in parallel to the start button so that when this contactor is energized, there's an alternate path to allow current to flow to the coil. So basically it will remember when it's on and will keep itself on. So let's run that. So I have my same setup. I will start, and so I have energized the coil, my contacts in the main power close, but also my aux contact closes on rung 2. And now I can let go of the start button and it opens up. And of course, there's still a path for current through the aux contact or through the contact on rung 2. So I'm still energizing my coil on contactor 1, keeping it energized, keeping it on, basically remembering that it's on. And now once it's on, it keeps itself on. It keeps telling itself to stay on because I have a path, an alternate path around that contact or that push button 1. Now, if I want to stop the system, I'd simply push the stop button, and there's only a single path series section of that circuit, so all the current runs through my stop button. If I open up the stop button, circuit is open. There's no more path through from the L1 through the coil to L2, so I disengage or de-energize the coil, opening up the contacts, opening up the rung 2 contact, and basically it forgets that it was on. I start the process all over again, start, let go, keeps running, stop. So this is now memory. So when I put a contact in parallel, normal open contact in parallel to my start, off of my coil I'm energizing, that's considered memory, a memory contact. This is a start, stop with memory setup. Very common. Anytime you want to have a start-stop station with memory, this is how you wire it. Okay, this is an industry standard way, just like power for a three-phase motor. This is my industry standard way of wiring it.